A generic type is a generic class or interface that is parameterized with a particular type. We have used generic before when we discussed about collections in Java. And I am going to share the link of the video in description below if you want to check it out. Let's start with an example without generic and understand why generic can be very useful. And then we are going to go and implement our own generic class. So for example, we can create a list and we can create it as new of error list and a non-generic implementation. And if we do that, we can add it to the list. For example, we can add 1, which is an integer. We can also add a string, which is a type of string. So you can see the add method essentially takes an object. So we can add anything we want here. But the problem with this implementation, first of all, is when someone accesses the value from this error list. For example, if we use for each here and we need to do operation with the item in the list. So if we take the object here, we can do one thing is we can convert it into int. And this is going to cast, no, I don't need this extra. This is going to cast the object into an integer. And then we can do something with this integer item. But the problem with that is in this array list, we have first item as integer, second item as name. So this is going to throw an exception when it goes through the second item as expected. Here, this is very simple example. We are adding it, but consider that the array list is passed to a method by some other function, in which case it's very hard to write a safe code. I mean, we can use type check if this is of this type and all, but the code will become very ugly and messy. This is where generic comes very handy. So here, if we just make it as a generic array list, which is an array list of type integer, now, first of all, we don't have to typecast it because we can just declare this as an integer and we should be good. The object itself is an integer. And you can see here in the second call where we're trying to add a string, the compiler is now throwing a compile time exception. It is saying that, hey, it is not a type of string, so you cannot add string to this array list. So this is where the generic type becomes really, really handy. Now let's create our own generic type. And for this example and simplicity, we're just going to create our own collection. So let's create a new class and we can say mylist.java. And what we are going to have here is internally here we can create our list. Array list is equal to new of array list, and it's a non-generic type. And what we can do is we can create a public void add, and it will take an object item. And inside of this add, all we are going to do is we're going to do a list.add, and we're going to add the item. We're going to get rid of the index. And similarly, we can have public object get, and this can return if list dot size is greater than index. So if size is 1, we can take up till 0. If it is greater than index, then it is going to return list dot get and at the index. Otherwise, just return Now, this is a very simple implementation, but this is as good as ArrayList. Let's say we want to implement this for this class, which is called employee.java. So what we can do is the mylist here can take employee, and then here instead of object, we can change it to specific employee, and we can return employee. Let's make it 10. And now you can see this is a very specific method. It takes an employee, adds it to the employee array list, and the get returns an employee with the index. So this is pretty straightforward implementation. And now if we go into the hello world.java, here what we can do is we can create var mylist is equal to new of mylist, and then we can do mylist dot add, and it takes an employee, so we can say a new employee name. And similarly, we can add other employees into the list. Now I have a vendor here, and if I need similar functionality for vendor, I cannot just go and add vendor here. Vendor doesn't have any constructor parameter, but if I cannot just add, it's going to throw an error saying, hey, this method takes only employee, not vendor. So this is the scenario where we want to convert our class as a generic class. So for converting generic class, all we have to do is introduce a type here. And when we create a generic type, we're just passing T as the type name. So here instead of employee, we can just change it as T in both cases. And for the add, instead of employee, we can say T. And for return also, instead of employee, we can say T. That's pretty much it. And then if we go here, now here we have to change because it's a generic type. So let's change it as vendor. And now we can pass vendor and it is working expected. But if we change this to employee, now the vendor is going to fail because we are saying it is specifically for employee. So we can change it to employee and pass a name. And now it will work for employee. So here we created a generic class called mylist, which takes a generic type. And then during declaration, we can decide what type of object we want to pass it to this type so that we can save and handle that kind of objects internally. Now, for a generic type, it is not necessarily we just have to take one type. We can have multiple types which can be passed as a part of the type list, and we can use these multiple types here. And also, which means here we need to pass multiples type. So we can say the second type is string and the third type is, let's say, integer. So this way we can pass multiple types and we can use them also here. I'm not using anything, but we can potentially use this code here. If we compile this code, it should just compile fine and run as well. Let's run and let's do a system.out.println and print out mylist.get and pass the index of 0 because we have only one. So let's compile and run, and we can see, so it is giving the entire object because we returned the entire object. If we want to print the name, we can set the name of employee as a public member so that we can access it from here, and then dot we can do a name, and then we can compile and run, and we can see the name which we passed here as name. So this is how very easily we can create a generic class in Java. So one thing also for generic class, we can create constraint for the generic type. So here we can say extends employee, which means the type that we are going to pass, it's need to be a type which is either employee or extends employee. So now here, instead of employee, if we pass vendor, it is going to fail because vendor is not extending employee. But if we go to vendor here, and if we just extends from employee, and let's implement the constructor. Now at this time, you see that we don't have an error here, and this needs to be just vendor, and we are good. The error has gone away. Again, if we go and remove the extend from here, we'll see that it's throwing an error saying, vendor cannot be passed because it is not a substitute of employee because the T extends employee. So this is all I wanted to cover for today's video, introduction to generics and how generic can be useful in day-to-day programming. If you like this video, please give it a thumbs up. And if you are new to this channel and you think you are getting value out of this channel, please subscribe to this channel. And thanks so much for watching this video.